Retaining walls are structures designed to restrain soil to unnatural slopes. They are used to bound soils between two different elevations, often in areas of terrain possessing undesirable slopes or in areas where the landscape needs to be shaped severely and engineered for more specific purposes like hillside farming or roadway overpasses. Definition: a retaining wall is a structure designed and constructed to resist the lateral pressure of soil when there is a desired change in ground elevation that exceeds the angle of repose of the soil. A basement wall is thus one kind of retaining wall. But the term usually refers to a cantilever retaining wall, which is a freestanding structure without lateral support at its top. These are cantilevered from a footing and rise above the grade on one side to retain a higher level grade on the opposite side. The walls must resist the lateral pressures generated by loose soils or, in some cases, water pressures. Every retaining wall supports a wedge of soil. The wedge is defined as the soil which extends beyond the failure plane of the soil type present at the wall site, and can be calculated once the soil friction angle is known. As the setback of the wall increases, the size of the sliding wedge is reduced. This reduction lowers the pressure on the retaining wall. The most important consideration in proper design and installation of retaining walls is to recognize and counteract the tendency of the retained material to move downslope due to gravity. This creates lateral earth pressure behind the wall, which depends on the angle of internal friction and the cohesive strength of the retained material, as well as the direction and magnitude of movement the retaining structure undergoes. Lateral earth pressures are zero at the top of the wall and, in homogeneous ground, increase proportionally to a maximum value at the lowest depth. Earth pressures will push the wall forward or overturn it if not properly addressed. Also, any groundwater behind the wall that is not dissipated by a drainage system causes hydrostatic pressure on the wall. The total pressure or thrust may be assumed to act at 1/3 from the lowest depth for lengthwise stretches of uniform height. Unless the wall is designed to retain water, it is important to have proper drainage behind the wall in order to limit the pressure to the wall's design value. Drainage materials will reduce or eliminate the hydrostatic pressure and improve the stability of the material behind the wall. Dry stone retaining walls are normally self-draining. As an example, the International Building Code requires retaining walls to be designed to ensure stability against overturning, sliding, excessive foundation pressure and water uplift, and that they be designed for a safety factor of 1.5 against lateral sliding and overturning. Types of retaining wall. Gravity. Gravity walls depend on their mass to resist pressure from behind and may have a batter setback to improve stability by leaning back toward the retained soil. For short landscaping walls, they are often made from mortarless stone or segmental concrete units. Dry stacked gravity walls are somewhat flexible and do not require a rigid footing in frost areas. Earlier in the 20th century, taller retaining walls were often gravity walls made from large masses of concrete or stone. Today, taller retaining walls are increasingly built as composite gravity walls such as geosynthetic such as Gale-Webb cellular confinement earth retention or with precast facing. Gabions. Crib walls. Or soil-nailed walls. Cantilevered. Cantilevered retaining walls are made from an internal stem of steel reinforced, cast-in-place concrete or mortared masonry. These walls cantilever loads to a large, structural footing, converting horizontal pressures from behind the wall to vertical pressures on the ground below. Sometimes cantilevered walls are buttressed on the front, or include a counterfort on the back, to improve their strength resisting high loads. Buttresses are short-wing walls at right angles to the main trend of the wall. These walls require rigid concrete footings below seasonal frost depth. This type of wall uses much less material than a traditional gravity wall. Sheet piling. Sheet pile retaining walls are usually used in soft soils and tight spaces. Sheet pile walls are made out of steel, vinyl or wood planks which are driven into the ground. For a quick estimate, the material is usually driven 1/3 above ground, 2/3 below ground, but this may be altered depending on the environment. Taller sheet pile walls will need a tie-back anchor, or dead man placed in the soil a distance behind the face of the wall, that is tied to the wall, usually by a cable or a rod. Anchors are then placed behind the potential failure plane in the soil. Board pile. Board pile retaining walls are built by assembling a sequence of board piles, preceded by excavating away the excess soil. Depending on the project, the board pile retaining wall may include a series of earth anchors, reinforcing beams, soil improvement operations and shotcrete reinforcement layer. This construction technique tends to be employed in scenarios where sheet piling is a valid construction solution, but where the vibration or noise levels generated by a pile driver are not acceptable. Anchored. An anchored retaining wall can be constructed in any of the aforementioned styles but also includes additional strength using cables or other stays anchored in the rock or soil behind it. Usually driven into the material with boring, anchors are then expanded at the end of the cable either by mechanical means or often by injecting pressurized concrete, which expands to form a bulb in the soil. Technically complex, this method is very useful where high loads are expected, or where the wall itself has to be slender and would otherwise be too weak. Alternative retaining techniques, cellular confinement systems, first marketed by Presto Geosystems as a registered trademark, have become increasingly popular for earth retention applications. They can be constructed as a gravity wall or a geogrid wall which consists of vertical layers of geochelles with geogrid reinforcement installed behind the face of the wall every few layers of the geochelle depending on design. Soil nailing. Soil nailing is a technique in which soil slopes, excavations or retaining walls are reinforced by the insertion of relatively slender elements, normally steel reinforcing bars. The bars are usually installed into a pre-drilled hole and then grouted into place or drilled and grouted simultaneously. They are usually installed untensioned at a slight downward inclination. A rigid or flexible facing or isolated soil nail heads may be used at the surface. Soil strengthened. A number of systems exist that do not consist of just the wall, but reduce the earth pressure acting directly on the wall. These are usually used in combination with one of the other wall types, though some may only use it as facing, that is, for visual purposes. Gabion meshes. This type of soil strengthening, often also used without an outside wall, consists of wire mesh boxes, which are filled with roughly cut stone or other material. The mesh cages reduce some internal movement and forces, and also reduce erosive forces. Gabion meshes, especially those filled on-site, have resulted in bearing failures, e.a. Oliver's Hill Gabion wall collapse, Melbourne unregistered trademark's worst $1 million mathematics mistake. When any wall is built above the slip failure plane, clearly it's going to slide, but this type of wall, by its very nature of shedding water, is more likely to be used where there is a slip failure problem. Mechanical stabilization. Mechanically stabilized earth, also called MSE, is soil constructed with artificial reinforcing via layered horizontal mats fixed at their ends. These mats provide added internal shear resistance beyond that of simple gravity wall structures. Other options include steel straps, also layered. This type of soil strengthening usually needs outer-facing walls to affix the layers to and vice versa. 1. The wall face is often of precast concrete units that can tolerate some differential movement. The reinforced soil's mass, along with the facing, then acts as an improved gravity wall. The reinforced mass must be built large enough to retain the pressures from the soil behind it. Gravity walls usually must be a minimum of 50 to 60% as deep or thick as the height of the wall, and may have to be larger if there is a slope or surcharge on the wall. Cellular confinement systems are also used for steep earth stabilization in gravity and reinforced retaining walls with geogrids. Geochelle retaining walls are structurally stable under self-weight and externally imposed loads, while the flexibility of the structure offers very high seismic resistance. The outer fascia cells of the wall can be planted with vegetation to create a green wall. See also. References: Ching, F.D., Fayer, R. S., and Winkle, P. Building Codes Illustrated, A Guide to Understanding the 2006 International Building Code. New York, New York, Wiley. Ambrose, J. Simplified Design of Masonry Structures. New York, John Wiley & Sons, Incorporated, Crosby, M. and Watson, D. Time Saver Standards for Architectural Design. New York, New York, McGraw-Hill. Commercial Installation Manual for Allen Block Retaining Walls, Terzafi, K. Large Retaining Wall Tests, Engineering News Record February 1, March 8, April 19, 2006 International Building Code Section 1806.1. AB Segmental Retaining Walls. National Concrete Masonry Association. Archived from the original on March 4, 2008. Retrieved March 24, 2008. Terzafi, K. Theoretical Soil Mechanics, New York, John Wiley and Sonsa, Leszczynski, D.A. Research and Innovation, Seismic Performance of Various Geochell Earth Retention Systems, Josses Synthetics, No. 27, No. 4, 46-52, Retaining Walls Industry. The Retaining Walls Industry web portal Italian Trivial is the #1 source of information regarding the building of retaining walls. Ambrose, J. 1991. Simplified Design of Masonry Structures. New York, John Wiley and Sons, Incorporated. Bowles, J. 1968. Foundation Analysis and Design, McGraw-Hill Book Company, New York, Building Code. New York, New York, Wiley. Ching, F.D., Fader, R. S., and Winkle, P. Building Codes Illustrated, A Guide to Understanding the 2006 International, Crosby, M. and Watson, D. Time Saver Standards for Architectural Design. New York, New York, McGraw-Hill. External links, Segmental Retaining Walls, Case Studies, Pictures of Gravity Walls, Information on the Design of Retaining Walls, Information on the Analysis and Design of Retaining Walls. NCMA is the National Trade Association representing the concrete masonry industry. Images of all types of residential retaining walls, information on the construction of retaining walls, Pink Rib, retaining wall design.